Hello. Good morning, everyone. Shared that a little prematurely. Hope you're all having a fantastic morning. Let's get this out to the good old community. This is our little Discord, if you are unfamiliar. Thank you for tuning in, by the way, guys. I'll have to get the chat up in a moment. Once I've got... let's make sure I don't ping some random guy. Yeah, today we are making infinite particles. Well, I saw like a cool article from like some undergrad. And we're gonna like be inspired by what he did. Yeah, so we're just gonna have fun today. Hey, let me just get up the Chessaroonie on my other computer. So I can see you guys all the time. Let's see. This will take one moment. I've done a bit of studying just before. Let me before I start yapping, let me try and get this done so I don't get distracted. All right. Let that load. What's up? What's up, Kevin? How you doing, dude? Thank you for joining us. Wow. Am I early? Yep. Hello, British matey. Spider-Man, thank you for joining us. Adamy, thank you for joining us. Yes. Thank you. Wow. Got a lot of people very quickly. All right. So the chat is open. We're on live chat mode, so I don't miss anything. Fantastic. All right. Cool. All right. First thing I should mention is yesterday I basically couldn't do anything. Not because of any extreme, you know, coding. It's so difficult. It's just literally I just didn't have time, and then I got a migraine at the end of the day, so that was, as you can imagine, very agitating. So, what are we trying to do today? We are your Linux maxing today. Fantastic. We are trying to see this particle effect, right? You've probably seen this before if you've been following these streams, but we have this lovely particle effect, and it does have an age to it, which I've set to 4 right now because I was making a new screenshot. And I want to make this just kind of like regenerate particles over and over again, you know? Because we're going to need that for like a rocket booster effect, so yes. We're just going to make it so it like regenerates these particles over and over again. As you can see, the particles do die, which is by design. I should mention as well, I fixed the lighting model if you haven't been here for that, which is cool. I'll let them die off. So, the asteroids are actually colored correctly. They were very brown before. Let's go full screen. So yeah, it's really cool actually, because I literally just did a simple mistake in my fragment shader. I was multiplying the specular color, which is reflective, and the diffuse color together as vectors, which is not often what you're supposed to do, right? You're supposed to add them together because they're supposed to increase the intensity of light. And so we have like actual gray looking rocks in space rather than brown rocks, right? Hello, Angelo Chris Cutie. YouTubers take such a long time to load the chat. So yeah, Angela Chrisacuti saw this yesterday, but that means also that our spotlight is now working correctly. You can see we've got like a torch effect. This is supposed to be so you can see darker asteroids. You know, if you're flying in this direction, right? There's not much light, so you should be able to see, you know, ahead of time that you're about to crash into a, you know, an asteroid, right? That was what that was for. But I had to increase the intensity to like 1 million before. Now it's only on like 10,000. It's actually like much lower, and I think the lighting looks so much better in my opinion. Also, occlusion. The occlusion textures make sense, right? So these dark patches actually aren't anything to do with indirect light or shadows. They're actually just part of the texture. They occlude light, meaning that they don't display light, right? So it like now, you know, if I go like this, you can see like what it's trying to do, replicate, right? Obviously this is just never going to accept any light, but you know, when you're not like right in the face of the asteroid, it actually looks kind of cool. So yeah, everything kind of like looks nice. The only thing we don't have is stable specular refractions, which I don't mind, to be honest. You know, you can see like the glitteryness of like asteroids in the distance when we move. I don't mind that. I feel like, you know, despite it being maybe a bit off, it kind of reminds me of like what ice would look like at a distance. So yeah, these are the two things that I got working. So yeah, we want to generate a particle effect, and let me show you that. Lol, even the brown. Lol is not even the brown. It was just a poopy shine. Yeah, exactly. I was highly aware that it wasn't looking correct. So yeah, I saw this fantastic article, honestly, on particles that this undergrad actually posted. Very impressive. Now I need to keep like getting better at stuff, right? So I can't remember. Compute shader particle effects. I think I typed in compute shader particle effects. I think with depth collision. So this is the idea anyway. We're going to be like looking at other people's like because particles aren't exactly like esoteric knowledge, right? It's not that difficult in the sense that like that's you know, particles that have hit the depth buffer, right? So there's a bunch of stuff that we can study. So I'm going to do a bit of studying today, and we're just going to like explore. And that was the other one, Mike Turple is in or whatever. I found out this guy has been around for a long time. I didn't realize who he was actually, but then I realized I subscribed to his YouTube channel. And I was like, oh right, okay, so he's just absolutely cracked out of his gourd. That's why he's like able to make some like awesome, cool stuff. And he's been programming for a very long time. So we're gonna look at that. And what was the other one? This one maybe? What was it? No, that wasn't it. Check out this abstract this supporting paper establishing formal mathematics and topology isomorphism between electrical integrated circuits IC design and subsurface network and subsurface fluid network. Hello Mika, how you doing, dude? I hope you had a good stream. Sorry I couldn't tune in immediately, but I hope you're absolutely crushing it. Meaning some parts of the world where minds are, they behave like natural big ass computers. Whoa, really? Oh. I wrote out the thesis. Wow. Oh, that's really weird, that. So abstract this oh, check out this check out abstract full stop this not abstract, this is one word. Thank you. That's like really badass actually, yeah. So I'm just gonna keep looking at resources because I wanna dig up the exact one that I had yesterday, because we're actually trying to it wasn't a Unity, I don't think. Let's see if it was. No, I don't think it. I think this is just like the straight up the Unity, yeah. Yeah, so let me just keep Googling until I find the right thing. Unfortunately, as we all know, search engines have got a lot worse. So something I found yesterday is going to be like impossible to find today, kind of thing. It might have been GitHub, I can't remember. It was a blog post. Not I think this is, yeah, this is it. Okay, so yes, we're going to be writing some notes on this, which is cool. I don't think that has dark mode, so I apologize for the lightness if you're in a dark room. Yeah, and I also want to talk a little bit, just before we start, a bit about outcome independence. I think I've talked about this before. Your mic is a bit of white noise. Oh, is it? Okay, let me bash it. All right, thank you for Angelica. Right, let me just I'll mute myself and then give it a whack. You usually fix it. Okay, so let's see how that goes. No, that didn't do much. Right, let me try again. Okay, so that looks like my levels are better, perhaps. I can always turn myself down a touch, so we don't get clipping. Yeah, no, we still got white noise. Let me just keep messing. Let me make sure the gain is off. That's always a big one. We're on cardioids. Okay. That seems to be better. I'm just looking at my own. I'm looking at this. Yeah, okay, so there's going to be some background noise, but I think hopefully that hissing should be gone, as far as I can tell anyway. I'll turn myself back up. Yeah, that looks better. Let me know if that sounds better. It looks better on here. I can't really hear myself, so let me know if that's good. Anyway, I think I've been stressing myself out. Yep, it's okay now. Thank you for letting me know, by the way. Your listening experience is very important to me, so it's always nice to know when it's not going very well. So anyway, I think I've been trying to do a lot of different things, and I've been putting pressure on myself to work, which is fine. But I think at the same time, I need to make sure that I keep this fun, right? I think I get sometimes caught up in the how much progress I make in a programming session, and if I'm not making enough progress, then it gets like really irritating. But that's just not a good mindset to have, to be honest, when it comes to this type of thing, right? I need to be having this mindset where I kind of just explore what we end up doing, and just enjoying making stuff cool, making cool stuff, exploring different things, getting better, and all that kind of stuff. So yes, so I'm gonna I've kind of picked this up when I was if you don't know, yesterday. Sorry to yap so much. I know maybe you're here just for the programming, but anyway, hopefully that's okay. I went to lift weights with my younger brother. I was teaching him how to squat for the first time. He's very strong, but he doesn't know how to squat very well. And he brought up the fact that he's not trying to focus on the outcome of his efforts. He brought up the locus of control as a 15-year-old, which was very impressed. And yeah, it was like kind of eye-opening to the fact that I should apply that to my own programming, not necessarily. I should make sure that I'm catching myself getting caught up and irritated by the things that are happening, and like getting hyper focused on the fact that I'm supposed to be making progress and there's this and that to do, and blah 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 blah. All these things that are like situational and life focused. So, whereas at the end of the day, this should be kind of like a nice exploration activity where we kind of like figure out what to do, and maybe people correct me in chat, and we kind of can't vibe the whole way through and do what we can, honestly. Success is not guaranteed no matter how hard you work. It just makes it more likely. And that's what I need to remember, right? So, hi, Nicholas. How you doing, dude? Do you ever use Claude Code / Codex? No. I just like coding so much, so I'd rather just chill and struggle by myself, basically. I easily squat. Yeah, it's he's strong. It's just he just needs a bit of coaching, effectively, to do it. He's I figured out yesterday he's been putting the bar too low on his back. He's not putting it like at the base of his neck. He's been putting it like really far, like where his shoulders are, right? Like where his shoulders, like below his shoulders even. And he's like, my arm gets really sore. I was like, oh, okay, right, let's let's put the bar a bit higher. Once I figured that out, he found it very easy, and he was able to squat for the first time, which is cool. But he still needs to work on his balance. So we're going to be working on that as we go. So he's going to get very strong very quickly. Anyway. Right, so we're going to look at this. The effect that we're after today, I thought this was really cool. This, right? We want to be able to generate multiple particles. I don't really care about the size as long as we can generate the particles like this. We'll have particle effects for like rocket boosters and stuff. You're doing the pregnancy workout. I see. Interesting. I kind of don't want to ask what that is, but I'm sure it's some insane thing. Right, okay, so yes, note-taking time. So if you're not familiar with how I take notes, I use this note-taking app called Obsidian. You know, it's an app which allows you to build kind of like a Wikipedia-like notes. And yeah, we're just gonna like, you know, figure out exactly what's good about this, what's bad about this. I think a lot of it's quite basic, but you know, this is the important part, the how to generate these things. A lot of this, well, some of this stuff apparently in this article has come from his professors. So yeah, it'd just be nice to you know, do this in the compute shader rather than, you know, worrying about it on the so this, I'm not sure if we're going to do colliding with a depth buffer yet, but maybe. Yeah, okay. Let me just sort out my obsidian so I can actually make some notes. But yeah, we're going to start off basic today and then kind of ramp up. We're just going to enjoy the process of learning today and implementing new things rather than worrying about the outcome, which is very tempting to get influenced by, right? Where you kind of, what is this? Creating a particle system. Yeah, so I'm sure this guy's got a fantastic job at some very good company at the moment. So, you know, it's I don't care how old he is or how young he is. You know, it's one of these things where I can learn from anyone. You know, if a 10-year-old comes into the chat and tells me I'm doing something wrong, I am all ears. Right, okay, so how I do this, for those who are unfamiliar, I read out loud, so you're not just listening to me read in silence and take notes and comment on chat. Yeah, so we're going to read this, and feel free to interject and let me know about things. Game dev related or not, it doesn't really matter. Your job in the stream is to have fun. So if that's how you want to have fun, then, you know, it's all good. All right. Hi, I'm Evan. At the time of writing this, I'm a second-year programming student at BUS. I don't know. Hi, Ethan. In the rendering equation, you have in your notes, did you mean to make the notation around the cosine term use angle brackets instead of the absolute value of cosine, since the angle brackets is for clamping from 0 to 1 and the absolute and bar I guess is the absolute value. Let me think about that for a minute. Is that the same thing, as far as I'm aware? We can look at our light transport equation again, and just have a quick gander at it. Good eyes, by the way. Nice catch on the on what it was about, because I didn't even talk about it. So let's just bring it up. Where is the... Right. Find what is the... Yep, there it is. Okay. So with angle brackets, that would clamp to... So I'm assuming that it doesn't matter. I mean, Ethan, if you're very familiar with graphics and stuff, and you know exactly what... I assume that the absolute value of cosine and clamping it to 0 to 1... no, it is not, since the absolute value would provide a positive value for normal facing away from the light source. Yeah, okay, so if we've got a normal that's completely facing the opposite direction of the light source, feel free to correct me here, but am I right to assume... Wait a minute. What would that do? So, if I open up Critter real quick... Right, feel free to correct me. I'm actually not necessarily a mega expert on this. I was revising this today. But yeah, let's load up this drawing app because it's much easier to draw on than Paint. And we'll investigate this. This is fine, by the way. I don't mind deviations like this as well. So I can say that I'm actually studying right now. Once this, I don't know why it takes so long to load this thing. It's a bit of a mystery to me, but anyway. All right, so just get rid of that for a minute. The reason I like this is because, yes, thank you. Go away. I need to use this. Thank you. Okay. Okay, so if we have a red... no, we want lines, actually. So we want to make a crude... Probably a bit thicker than that. No. Okay, that's way too thick. So yeah, that'll do. So if we have like... oops, there we go. Like a plane like that, but the normal is... Let's just make a new color. Let's go straight down. Obviously this is assuming uniform length, right? So so that's the normal. All right, and the light source is literally here. So let's make this a bit bigger, like that, right? So you're saying that the lights, if the light is here and the plane is there, then the light transport equation is then going to be picking up light as if the normal is, let's just make another color, but make it small again. It's about there. As if the normal is here, right? Like, so these are going to be equivalent. Because the light transport, as far as I'm aware, this is just a normal map again. As far as I understand it, this is to do something like indirect lighting. It's come from a ray tracing book, so you know, obviously, like let's just say bounces off there, bounces off there, and then like bounces up here, right? You know, in theory, if with a path tracer, that's like kind of possible to happen for indirect lighting. But I could be completely wrong here, where the cosine is maybe doing the wrong thing here. With it, we have this blue and pink are kind of equal. That's what I thought this was about when it comes to lighting. That's why we have this absolute cosine. But I could be completely wrong here, where I look like. If I was to, can I just go into Desmos for a minute? I'm a bit tired today, so you know, forgive me if I'm a bit completely wrong with my maths here. So can I just do double bar cosine of x? So that's what it would look like, and if x was negative, if we had. So I assume that's direct. Yeah, it might be right, actually, thinking about it, because I don't really know how this model would work. In the sense that if I got rid of this, obviously we would have that, right? But if we can we clamp on this? I don't know. Oh yeah, we can. Cool. The cosine to 1, 0. Is that a thing we can do? Probably not. I got a big decided probably. Oh, mathematical notation. You literally said the mathematical notation. Maybe this is a thing that we could. No. Okay. I don't know how to represent a clamp on Desmos. Remember that you're integrating over the whole hemisphere. So it wouldn't make sense for there. Okay, let me read that again. Remember, you're integrating over the whole hemisphere. Yes. So it wouldn't make sense for there to be a vector outside the hemisphere to contribute to any light which is okay, wouldn't make sense. Okay, remember that you're integrating over the hemisphere, so it wouldn't make sense for there to be a vector outside of the hemisphere to contribute any light is what a negative cosine term means. Oh, I see. Yeah. Okay. So, yeah, that makes sense, I guess, because that's why we have this idea, right? Can I do a hemisphere here? Yeah, maybe not. I wouldn't know how to do that. Maybe a spline. No, I'm not going to try and risk it, but I see what you're saying. Go away. Okay, so I can only undo. But effectively, yeah, if I go to paint or whatever, let's change the color again just to be sure. You know, if we're only interested in this blue, we are doing this hemisphere, and the negative cosine would be, I guess, so this is going to be, this is incorrect. So again, I'm just going to change another color. So this is the obviously not, oops, this would obviously be the incorrect part, which is the, you know, only the so as far as I'm aware, that I don't know. I in the book, right? Let me look this up in physical. Hello. Let me look this up. And get the actual source that I got this from. I'm going to traumatize people who were with me when I was reading this. So I thought this at the time was going to be about physically based rendering exclusively. But no, it's basically a ray tracing book. And I believe this is roughly this is where I robbed it from. I'm gonna have to find it. Okay, so yeah, this is the actual maths that I stole it from. As you can see, it's basically the same. You know, same deal, right? So, we can get to the negative cosine part, if we can, if I can see it. In general, the amount of light reaches the camera from the point of an object is given by the sum of the light emitted by the object, which is this. If it is itself a light source, and the amount of light reflected back. The idea is formalized by the light transport equation, also known as the rendering equation, which measures light respect to radiance, a radiometric unit that will be defined in section 4.1. It says that the outgoing radiance, what is that called? That's called the so this light emitted radiance is the other one. I can't. Oh, did I write it down? I didn't. Okay. I've forgotten what this means. I think this is the oh no, that's the actual finish of the lights. Duh. This is the actual function light sort of equation. From a point P, a direction omega O is emitted. Is the emitted radiance at the point in the direction of LE, yep, plus the incident radiance from all directions over the sphere around the point. Ah, right. Okay, so this is a sphere. Ah, right. Okay, this makes more sense now. Yeah. Often when you study this is a this is a hemisphere, so maybe this is the maths that's different. Around point P, scaled by the BSDF, which is that thing, and a cosine term. Right, okay, that makes a lot of sense, right? Why is stream delayed so much? Actually, oh, thank you for the sparkles. Thank you. Your sparkles didn't show up on screen. I tried to get it to work, unfortunately, because I'm on OBS now. It didn't want to do it. I do apologize that your sparkles didn't show up on screen, but I'll make a big deal of it. I will try and get it to work. I know some donations work, but not all of them. Anyway, oh, okay. I see the integral wouldn't have a positive cosine term. I was thinking for your case of rasterization, you should make sure that the clamp term, since you're calculating the light directly. Oh wait, I didn't see that. Oh, okay, right. Stream delay is a YouTube thing. You should multi-stream on Twitch. Yeah, I think I will one day. I might do that tomorrow. Actually, we might screw it. I might just like throw it on Twitch and see who wants to join in. Thank you, Ethan, for clarifying that. Honestly, because it's like when I was learning this, just so you're aware, Ethan, I was so totally unaware that I was learning path tracing things at the time. I was like, oh, this is just standard. This is what rasterizers do, right? I didn't really even know at the time when I was learning this that there's a difference between... oh my goodness, thank you for the 100 for the tool jewels. That's very nice. Again, I'll make a big deal of that. That's very nice of you. There we go. There it is. 100. So at the time I was kind of like, okay, this is like how you're supposed to do it. As far as I'm aware, the reason... Okay, so here's what I understand by this, right? The reason that you do it, maybe... Okay, so feel free to correct me for path traces anyway. With the BSDF, the bidirectional scattering distribution function, rather than a bidirectional reflectance function, you know, because we have the transmission function added to this as well, for the reflectance. Reflectance and transmission kind of added together. Bidirectional ones anyway. You do it over the whole sphere because you're simulating how the light, how you get subsurface scattering. But when it comes to rasterization with the BRDF, which is different, you are over a hemisphere, meaning that you clamp between 0 and 1. Because we're not actually... that's actually really insightful. Thank you for that, Ethan, because that idea had not connected in my head. So we're actually gonna. This is what I want. This is what I wanted to get back to. Is like this exploration of stuff, right? So that is actually really cool. I'm gonna write down what you said and maybe make some notes on that because that's actually really insightful. Thank you. Thank you for the like. I don't mind going completely off track. Thank you for the 6 chilies as well. That's also very, very kind of you. There we go. There he is. Thank you for all those. Thank you for all those jewels. Honestly, it's very much appreciated for supporting the stream. Right. Okay. Right. Stream stuff. Right. I'm gonna write that down. Ethan has told me, or made the observation that, hopefully you don't mind me writing it. I often when people teach me something in a stream, I'll write it down and like make notes on that. So hopefully that's chill. That the light transport equation is for a full sphere because it's doing doing subsurface scattering. Yeah, eat some chili. I actually really like chili, so yes, it's not a problem by me. Subsurface scattering rather than the bidirectional reflectance. Oops. Bidirectional. Oh, that was right. Bidirectional reflectance function. Yeah. BR. No, it's BRDF. Wait. I feel like I'm tripping right now. It is BRD. Yeah, okay. Bidirectional reflection distribution function. That's actually what it stands for. Okay. Slightly wrong, but there we go. Which, in rasterization, graphics, I guess. You are only interested in how much light is reflected back at the camera, meaning that you do the integral over a hemisphere, not a full sphere. Okay, next. This means that you... I'm just going to grab the equation, because it's all latex, so grab that. This means that the light transport equation here. Now I do actually have the other one as well, so we're going to grab that wherever I can find it. Let's go back to here, go back to graphics theory, and I think I have this in the IBL. Yeah, okay, so this is the other one. Is more like this. All right. Yeah, so that's the one on the where learn OpenGL, where the... I'm just going to grab the n.l because that's the cosine right there. It's just in dot product form. Now where is it? C dot. Right, is that the... Yep. Is the cosine of theta but because it's over a hemisphere, it's it should be clamped to 0 and 1 because we aren't interested in anything on the other side of the sphere. Other side of this. Thank you. Okay, I think that's about right. My understanding is a little bit off, but I think it's 0 1. Yes. Okay. Clarifying. Thank you again. Yes. There we go. So I'll formalize this probably off stream. Kind of like add a few more extra notes maybe. But yeah. That has actually been. I've been looking to connect these two ideas. I understood that something was different. I didn't quite know. Actually, that's slightly wrong. It's if we're going to use the BSDF, then we're going to have to make this into a in the rendering equation. That is how it's written. Sorry, in the what is it called? The this book, physically based rendering. It's a good book. If you're actually interested, it is free online. But the problem is, it is purely for offline ray tracers. Because you do have the BSSRDF, which is, I think the acronym's starting to lose any meaning at this point. But yeah, bidirectional subsurface scattering reflectance distribution function, which is way too complicated for any real-time renderer to bother with. And it's supposed to that just out of curiosity, if you don't know what that does, is if light, it also deals with how much light is emitted back out of something like skin. So So this is what this is about here. Yeah, sorry about the face reveal. All right. Cool. Yeah, feel free to, again, anyone who has any other, if you do spot a misunderstanding in my, or you want to question something, I'm always welcome to that feedback. Right, let's, where were we on? All right, cool. Right, I'm just going to grab a drink real quick. I completely forgot. I was a bit too excited to stream today, so I'm literally in the kitchen, so this will take me like 2 seconds. Let me just make this big. All right, so you'll still be able to hear me. I just, my migraine from yesterday is still bothering me. I need a bit of water. All right, and then we'll tackle the our particle system and try and make it nice. Okay. Water acquired. Yeah, don't get migraines, guys. Do not recommend. It lasts for ages. Don't go away. All right. We're not gonna let that stop us, though. Okie dokie. Alright, so yes, we're just going to assume that I know nothing and just take notes on things that I need to know. Anyway, okay, so hi, I'm Evan. I said Ethan last time. Oh, no, I didn't. That's the guy who's been talking in chat, that's why I remember Ethan. Anyway, hi, I'm Evan. At the time of writing this, I'm a second-year programming student at BUAS in the CM... Alright, whatever. Over the past 8 weeks, I've been working on implementing a particle system, a project I was able to choose myself with some guidance from my lectures. In this blog post, I'll explain how to implement said particle system using compute shaders to simulate particles in OGL. This article requires some understanding of OGL and C++, but nothing too complex. Okay, cool. Right, so I think a lot of this is going to be... Obviously, he's written this because... I think this is like a portfolio piece. So yeah, give this guy. I might give this guy a like on his GitHub because it's cool that he posted this. Anyway, why on the GPU? Okay, my implementation of particle systems is done on the GPU using compute shaders to simulate particles. This is because the GPU allows for much larger simulate particles. This is because the GPU allows for a much larger quantity of particles to simulate. It can perform computation much faster on the CPU than the CPU. I specifically chose the compute shader in GLSL, so I haven't used shaders in GLSL as I hadn't used them before and was interested in learning about them and how to use them. Very cool. I think we're all familiar with that. Oh, thank you, Gemma. So I'll just post that. Thank you for the good morning, and hope you're having a great morning, and the lovely 2 joules. Again, I'll just display that on the screen. Thank you very much. Gemma, yeah, we got a. It's the alternative. I don't know if Gemma knows who Gemma is. Anyway, generating particles. Particle emitters. To generate particles, we need particle emitters. This is thing I don't quite understand the particle emitters thing. Like, it seems like every particle has this, and I don't really know. It just seems like a place where particles come from. I don't really know. It doesn't seem like a formalized idea. It just seems like everyone just decided to call the place where particles are particle from, I guess. That's it. Gemma is the female Gemma. Yeah. Yeah, just so everyone knows, yeah, Gemma is a funny streamer. These will contain all the info we we'll need to generate particles in this implementation. Particle emitters are a component like are components linked to an entity in the ECS. Okay, so you're using ECS. This entity has a transform, which is what I use. Is the music still going? Let's just get the music going again, wherever our music is. Oh, did I close the music? Why did you stop? All right. Sometimes the music just stops. Apologies. Let's just get this going again. This song is so good. My old twin, yeah. Exactly. Well, it's a good evil twin to have, I have to admit. This entity also has transform, which is used to get the position and rotation of my emitters. And ECS isn't necessary for the particle system to work, but I am mentioning it as the code snippet may include it. Below is some implementation of the particle emitters. So it looks like this is C++ side. We have a similar idea, but we don't use max and min velocity and stuff like that. So we're much more basic right now because I want to minimize the amount of stuff that's on the GPU. You good, genius? Ah, thank you. Yeah, I'm good, thank you. I definitely wouldn't call myself a genius though, but thank you for the compliment. How are you doing, dude? Hopefully you're having a great day, whatever you're up to. Yeah, there's still stuff I just love coding, so I just, you know, every day learning new things, regardless of where I'm up to or how dumb I am. That's how it should be. Anyway, okay, yeah, it's just data that we already have. The particle emitter is implemented as a class container. Class that contains minimum and maximum values for various attributes that are used as a range to select from when generating particles. There also a couple of variables. Variables mean just for emitters. Spawn interval is the time that has to elapse before a particle is spawned, and the timer keeps track of the time. Yep. Max particles is the meant to be the cap of the amount of particles that can live at once. I never actually maxed out the particles. I never think about it. Anyway, created by the emitters. The buffers at the bottom of the struct. Our buffers will bind to use the computer shader. They are just meant to hold the buffer's ID. I decided to implement a couple of functions to make binding them. Oh, okay, so this is a OpenGL specific thing, right? Yeah, with binding buffers and stuff like that. We don't do that in Vulkan, but that's fine. As long as we're aware that this is very OpenGL based. Anyway, later on we'll pass this data to the GPU. We'll use a different struct I called emitter settings. So we send useful information to the GPU. Below is the implementation of the emitter settings. Okay, so we have more or less the same thing. We just have a slightly different setup instead. Why the padding? Okay, so he's just going to explain what padding is, I think, but let's just go through it anyway. You might be confused as why there is padding between some of the variables. That is because of the way GLSL stores. It's probably more accurate to say buffers, but that's, you know, the GPU. But anyway, below is the implementation of the emitter settings in the compute shader, right? So yeah, blah, blah, blah. Yeah, cool. As we can see, there's no padding in GLSL version of the struct, at least not visibly. Using standard 140 or 143 as a layout means that the vec3s are treated as vec4s. Okay, yeah, so that is... We already know the padding rules. We don't have to worry about that. An SSBO, shader storage buffer object, is a type of buffer that sends... so, I don't know, maybe I should read this to the people who aren't necessarily, like, on... who haven't done this before. Okay, so yeah, I feel like I'm going too quick here, because not everyone is, you know, familiar with this idea. So okay, so when you have a struct in, you can see it here in my shaders. Sometimes you have to add padding values, which mean everything needs to be a divisible. Sorry, a multiple of 4. Sorry, everything should be treated as multiple of 4, and it should be, you should have 16. So there's like, let me say, how do I say this? So yeah, vec3 is a tree. There's like rules that you need to follow to make sure that the padding of the values that you're using are, let's say multiples of 16. But even then, you don't have to. You have to basically follow rules, otherwise there's. And this is for efficiency. I don't think it's actually true. That's 16. Anyway, so here, for example, if I had like, you've also got to consider as well that if you have multiple buffers, for example, here we have an array, we have to pad at the end. You wouldn't have to do this with a uniform buffer object. But these structs will be packed next to each other one by one, so they need to be in a way padded so they're evenly distributed over an array of values, because this would be an array, right? For each particle set, we have an array of particle sets. These need to be even. Now, the reason that the GPU wants to pad these things is for speed. So it's a bit of wasted memory, as you can probably imagine, but that, you know, comes with the fact that the GPU doesn't have to do a bunch of like weird, you know, calculations here. It can assume that everything is aligned in a way that makes sense. So you can have like a vec2 here, for example. That'd be fine because it would eventually hit the 4-byte boundary. Sorry, 16-byte boundary, where it'd be like 4, like assuming that it's 4 floats, right? And a uint is also 4 bytes here. So, you know, if we have like vec2. Oh, why am I not typing? Okay, Visual Studio is crashing. Again. Give that a moment. Yeah, I don't know why this happens. Like, yeah, I don't know why that happens. It's a very strange bug. I don't know, maybe the AI slopped that together. Slop coded stuff. Anyway, it's always weird. It's like when I write a comment in a shader, it breaks. It could be the extension, to be fair, but anyway, right, so let's just say we have a vec2, right, plus a vec2, right, that equals a vec4, and a vec4 is made up. Are you kidding me? It's crashed again. All right, so maybe I need to disable something. All right, I have no idea what's going on. I encountered alignment issues with all types of computing equipment. Hello. Thank you for joining us. So, for those who can't read Dimitri's Russian, I will read that out loud for you guys. And that's what Dimitri just said. Yeah, I don't know why this is causing a crash. I think it might be the extension I'm using, so I'm just going to try and disable it. Because I can't imagine like writing comments is causing issues. So let's disable you. Right, so let's just make sure this doesn't happen again. Right. Yeah, it's been happening a lot more recently, the crashing. Right, perfect. Now everything's grey, which is miserable. I did think, let me just manage my extensions one real quick. No, this is what is this? Why is this installed? I think I tried to uninstall this, it just didn't work. Let's go with, is there a GLSL highlighter that isn't ass? Yeah, why aren't you showing up? Am I installed? This is enabled. Okay. What? Oh, whatever. I don't know why that isn't working. It is yes, AM. Yes, so good morning. Thank you. Thank you. I assume it's good morning for you. I'm gonna say good morning. But anyway, okay. So we have like Vec2. I feel like I went too quick over this. So you need to make sure that the alignment is padded in a way that, let's just say I have a Vec2, then an int, right? So like a float. I say float, right? We're all familiar with this. So this is 8. This is the equivalent of 8. 8, which is 2. 2 4s, right? 2 times 4 is 8 plus 4. And then I have, let's just say, a Vec2 again, right? And then I go plus 8, right? So we have, what, 16, and we have 20. This is equal to 20. The problem is this isn't 16 byte aligned, right? So if I was to, this would need to be 16 to be happy. So you might need to rearrange this in a way that would be like, all right, so put this here like this, so it'd just be 8 plus 8. That'd be 1. That'd be 16. And then we do a float, which is fine. We do, again, 4, right? But assuming that this is just going to be an array, this also needs to be, you know, aligned by 16. So then we need to add what, you know, float 3, which is like 3 extra floats. So that would be plus 8 times 3 is 24, right? No. 8. No, 16, sorry. I might lose my mind here. Oh, it's 4. What am I doing? It's 4 times 3, so it's 12, right? I thought it was 8 for a minute. 12, right? And if you add these all together, you get something that's divisible by it should be 32, right? So that's like 16. So that's why you add the padding in. And this is important if you have. Can I duplicate this? Yeah, this happens, right? This is like an array version where it needs to be aligned over and over again for each array element. Otherwise, things start to go wrong. So now I found that you can have the scalar extension, but when I use buffer device addresses, so when I have a shader storage buffer object like array of buffers like this. Let me say that again. If I have a buffer where it's like an array, I'll just say it simply, and I use a and I try to access with the buffer device address, the padding of multiple structs in that array doesn't work. Okay. 4-hour difference. It's good afternoon. Well, there we go. I was slightly wrong, but I'm glad you're here. I hope you're having a great Sunday. All right. Anyway, so that's enough of. Hopefully that made sense. That's why I'm skipping over this. All right. So emitting the particles. So there are steps. First to spawn them in. The first bind correct. Let me. If that doesn't make sense, I can always explain it better. But after binding the shader program, we loop through all the emitters in the scene and update their times. Yeah. Dividing them by the spawn time gives us the amount of particles that are spawned. Okay, so we need to so after binding the program, we loop through all the emitters in the scene and their timers. Divide by the spawn intervals, giving us the amount of particles spawned this frame. Okay. If no particles spawn at this frame, we skip the loop. So this is on the CPU side. He is doing all what I just said. Do we care about this? particles to spawn are... So, okay, so we bind the buffers and uniform necessary for the compute shaders to spawn particles. However, we still need to calculate how many groups we will need for the dispatch compute call. Ah, okay. We get the work group size from the compute shader and the particles that need to be spawned to this frame and and calculate the minimum number of groups need to be spawned for all the particles. So as far as I'm aware, this is calculating the yeah, so number of work groups. Yeah, so we want to obviously do the minimum amount of work here. Per thread. I thought you were doing this on the compute shader. Yeah, okay, so particles to spawn is this calculation up here. So we guess the okay. And if I look at his struct again, he has... Does he have data in here that stores the... spawn interval? Yeah, what's that? Hello, hello. How you doing, dude? Good morning to you, I think. Maybe. Good afternoon, perhaps. Right, so as far as I'm aware, I don't see the... So it seems like for this guy who's written this, every emitter has its own time, but it's not stored in the compute shader. He has an extra struct here that stores the time for each emitter. And then he knows the spawn rate based on a couple of variables. If I scroll up, maybe... Is it here? Okay, here we go. Spawn interval timer. Yeah, okay, so there's a couple of extra details here that might be worth doing. The problem is with that... let me think about this. Good afternoon. I see you. There we go. Okay. Let me think about this for a minute, because is there a problem with storing the time, the delta time, and then working out the spawn interval per... Okay, so we don't really need to store the time. We can just not do that. We can just send it in via an argument. And the second thing is the spawn interval, which I think does the compute shader stuff, and how many particles are emitted are based on this like standard calculation for workgroup size, which I've done before, but I've stopped recently. I can always bring it back though. So it seems like for the X component, which language is this? This is C++. Yes. Vulkan and C++. We're working on particles today. I'm just exploring like how to do particles, which I'm really excited about. So yeah, we're doing up. We're just going to see like how we do this. You know, it's really interesting stuff. And if you're not sure what I'm talking about when it comes to particles, if you're unfamiliar, we have this. You know, we have this like particle explosion, which kind of like lasts for a long time. But I want to keep like spawning in the particles after they die, because they do die eventually. And that would be kind of cool for like for another type of particle effect. You can see eventually they get deleted. I think you have to wait roughly about 6 seconds. Yeah, you see them starting to disappear. I've left them a long time so I can actually see them. Yeah. Anyways, Yeah, it's all fun stuff today. All fun stuff. Right, okay. Now, the question is, when I spawn the particles, and I calculate how many particles I want to spawn per second, I do this by this calculation. And then what I want to do is basically generate do a VK command, compute dispatch, and then how do I reset things though? That's the question. For me, I'm writing this all to a buffer. And let me see here. So what is he writing to, which is my question. Particles per thread. So he has global invocation of U particles per thread. So this is a uniform he's passed in somewhere. As far as I'm aware anyway. Will that cause memory problems with so many particles? The idea is that, for me anyway, I'm generating these on a compute shader, meaning that it fills up a buffer of data, and that buffer increases how many particles are on the screen. So that would eventually like cause a massive buffer and be a bit of a memory issue. But as they get deleted, I remove them from the. Well, I don't remove them necessarily. I just what I'm going to do is overwrite the positions of those particles. So they're not, once they're hidden, they become inactive, and I can check if they're inactive by their age. And if their age is over a particular value, then I reuse them for another thing, right? And now I've said that out loud, I think that's how we're going to do it. So we'll have to see anyway. So if I just do a really cheap hack, let's just try it out, what I just said out loud. So if I hate no syntax highlighting. If right, so this is the continuous integration over time, over just velocity, because we're just doing velocity right now. If yeah, if the age, right, this is just a quick, I'm just gonna try this out. Why doesn't Visual Studio support this? It's so poop. But let's uninstall this and see if it goes away. I'll leave that for now, and maybe this will like kind of work, because I really would like to. I would prefer to see this. This is but it never really. I'm just going to close this and see if it needs to. Yeah, okay. So it needs to happen at the end. Yeah, just bear with us, guys. So yeah, this might be not as complicated as I thought. Yeah, so modify, get away. If I just have the different settings for these particles, and assuming that I want to respawn them, then I can just set up a compute shader that does that. But I don't know if it's like how many emitters per second I need to do. I think that's the disconnection that I have. I need to have different compute shaders running in tandem with each other, and then what I can do is pull that data out. Sorry, I can pull out data structures that generate these draw calls. No, sorry. I can run multiple compute shaders that all write into the same buffer, assuming that they're offset from each other, which is going to be tough. That's going to be the hard part, because I want to make like as few draw calls as I can for each particle, right? And if I have multiple emitters all spamming out particles every frame, that also needs. I need to also have a way of knowing what particle to overwrite and what not, and what particle not to overwrite. So I need like a way not to write them into this position, I think, after the age is increased. We can do it maybe with the active set. So let's just manage our our extensions again. And it's installed, but it's not working. Right, I'll uninstall this as well, and... Oh, is this only for inline? Oh. Boo. Boo, boo, boo. Okay. Never mind. It's only for inline, so I think, as far as I'm aware, we don't have syntax highlighting. So we might just use a different editor for this, for our shaders, because this is just too annoying. So yeah, let's just open up GIMP, not GIMP, Notepad++, because it's just going to be awkward otherwise, and I don't want to have to keep crashing Visual Studios because this extension is starting to break. Alright, so I'll come up with a better solution. Will one particle occupy one shader unit? Right. So I don't think I need any of these. These are mostly scripts. No. One particle. Yes, actually. Well, there's going to be one compute shader that handles one particle. But we're going to have multiple invocations of compute shaders, right? So, just, yep. Music is good. Alright, keep going, keep going, keep going. No. Actually, let's just close all. Where is the... How do I close all but this or something? Yep. No to all. Right, okay, cool. Get rid of that. And now we can open up our compute, our shaders. So open. Interesting. Oh yeah, I was trying to get dynamic rendering working. That was a while ago now. Moving away from render passes. All right, so obviously we don't want SPI-RV in here. So or slang.slang. Whoops. And we don't care about this. Okay. Hopefully that's not going to open up any binary. Right, cool. And then we want to go into our compute shader, which is what we've been working with, which I'm just going to pin. And sorry about the faff, but you know, at the very least we can go into C, which is going to help me just not make less mistakes. Anyway, right, okay. So what I'm going to do here is, yep, it does. It's I can't select this to be like C or something. It's quite annoying. Like, I can't tell it what language it is. So yeah, without extensions, maybe there's a way of doing it, but you know, at least here I can see kind of like, you know, what it just makes things so much cleaner. The only downside is I won't be able to see mistakes, but that extension kind of broke anyway. Anyway, so okay, based on this particle set, excuse me. If I so we are going to do this for now. We're just going to constantly reactivate the same thing. What I want to do is so if this, so it's just the opposite condition here. Else, what I want to do is take you guys and reduce them size to a vec04. So 0.f, 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 0.f. I'm also going to reduce this, the age, I think, to like maybe a lot smaller. Particle set is the same. Yep, everything else is good. All right, cool. What's the name of the game? Hi, Void. I don't really have a name for it right now. It's currently a codename The Space Game, right? I think I even have the title of the game called The Game. Just terminal notepads have LSP. LSP. Flying Duck Adventures. I like that. Yeah, maybe that's a cool, better name. Anyway, so if I then compile the shaders, what do we get? New position and age is undeclared. Oh, did I send them out? What do you mean you're undeclared? Is particle set here? You should be... Okay, let's just check it's saving. Okay, it is, yes. And line 64. 64. Oh, yeah, you're right. Okay, so... Yeah, this needs to be calculated, I guess, at the end. Okay, so some of this stuff needs to be taken out, which is... Yep, okay, that's fine. I don't think it's that big of a deal, but there's a bit of extra calculation. But we also need to know, like, what the next... To know what to do next, right? Alright, so... Let's reduce the age of... yeah, I'm just using, extended support, yeah. I'm using Windows 10 extended support. So, let's reduce this to 0.3, so it's like a lot shorter. I'm going to increase the speed by, let's say, to 150, so it's really fast. Yep, so that should be good. Let's give that a save, and then let's give this a run. So let's see. Yeah, there we go. So we have a particle emitter that doesn't stop. Yes, I haven't ordered the transparency, but that's basically that's going to be happen further down the goal. I kind of like that. Very cool, very cool. Okay, so so that's for 20,000 particles. This is all worked out in a compute shader. The problem is, though, that this is fine. Let me think about this for a bit. So this is also done in one draw call as well. This is instant rendered over one indirect draw call. Let me think for a bit. So that's honestly what I wanted to do today. Obviously we can do more, because that's going to be useful. Assuming that I get the maths correct, we can do more, you know, a thruster effect, right, based on this. Obviously it won't have the same, it'll have like less it won't be as fast, right? Right, okay, so what are we trying to do next? So that was very easy, actually. We didn't even have to study that other stuff before. We just reset the age. The problem is, with this approach is, yes, this will work perfect for one emitter. Oh, this has gone through many iterations, so about 6 months so far. But this is like, this has come from a lineage of different game engines that I've created over the years. Okay, so this compute... So the problem with this is we just have 20,000 instances of a compute shader running to generate these particles. And that's fine for one emitter. But the problem is if I have two emitters, then like how does that work? Hello, hello, hello. Hi, how you doing, dude? Alright, so what I'm saying here is, let me show you what I mean. Because it's kind of unclear, I think. So if I bring this emitter in, so this is like another emitter, right? And I put this to like 10k and this to 10k. And the only difference here is the position and the color, right? Now, this might look good, I guess. I don't know yet. Okay, so that's the concern right now, right? Now, these particles are kind of overwriting the, wherever the blue one went. Yeah, the blue one is for some reason not doing... Why is that not doing anything? Give me a minute. What are you doing? Why are you always... Oh, yep. Oh, that's true, actually. Yeah, hang on. Yeah, let me do that again. I just realized there's like a I'm trying to demonstrate like a terrible thing at my engine at the moment. I think that should work. It's not very good at all. Yeah, there we go. Okay, so if we turn this off, we have a lot of particles. I assume the bit rate is getting absolutely destroyed by this. I do apologize. But you can see like, oh, this looks cool, right? We have two particle effects that are going on. We have a lot of explosions or whatever. The problem is I'm doing a lot of wasted work here. I'm like trying to generate 20,000 particles for this blue one. Now the bit rate is okay, cool. And 10,000 particles for this one. The problem is that I'm having to generate twice as many particles here because this particle simulation overwrites the data of the first particle system. So what I mean by that is if I have a... you know what we need? This is dead simple, actually. In our... let me think about this. I think we can solve this, like, dead simply. So let me... So feel free to scream at me and tell me I'm a poop head or something if I'm doing something insane. But what I'm going to store here is an offset into a buffer. Right. So give me a minute. In a push constant for now, because I haven't really decided. Let's get rid of this. So if I go into... I've just had an idea, right? So yeah, it needs to go in here. Otherwise, this will completely crash the GPU if I don't do this, right? Offset. All right. So I'm going to do this first, then go back to the compute shader. Oh, it needs... Why am I making it a float? It needs to be an int. That was stupid. Yeah, if you're going to do an offset, it's definitely not a good idea to have a floating point value for that. I don't know what that would do on the CPU, on the GPU even. So an offset and compute shader. Nope. Compute shader. Yeah, it's going to take me a minute to get used to that. Uint, not unit. Offset. Now, are we going to make sure our buffer is wide enough? But as far as I'm aware, if I have data index plus offset everywhere, so if I have like that, for example, And everything should be okay as far as I'm aware. So if I go into... let's get rid of this. And I go into... here. So this may be a terrible idea, but I want to see if it's kind of like offset at 0. And then offset... Let's just do 20k each, because that's as big as my buffer is at the moment. So offset... sorry, it is 40k in size. So... sorry, 20k, right? Exactly. To infinity and beyond. Dr. Eggman is stealing the particles indeed. Alright, so here's my crazy idea. So originally, I definitely remember making a buffer that's 40k in size. And I offset into that buffer so I don't overwrite the originals. And I can probably dynamically change this, assuming that we don't have an infinite particle simulation, right? So let's just have a look. This may just completely crash the GPU. I don't think it should. Alright, so we have that, but we don't have the... Oh, disappointing. So we're trying to get the red one to turn up as well without setting this. Hang on, if I go to my compute shader, did I set this up correctly? Offset plus that. And for this compute shader it is 20k, which means we should be up, you know, beyond the values. Yes, we are still listening. Let me think about this for a minute. Like, why aren't you displaying? I think my idea was pretty solid, to be honest. I mean, I can probably kind of... Let's just check, right? Let's just check this works. No, that's not going to work at all. No, one instance does need to be... Okay, so offset... I don't want to do this because this feels like a stupid waste, but I don't know if that addition is affected. Right, just bear with, I know this is kind of like a waste of like I definitely won't have this for a long period of time, but yeah, bear with me. Right, so we do this. Nope. And we don't have any red. Alright, so that didn't mean anything. I just wanted to... That was more of a sanity check than anything. So... Why are you having the same value? It almost feels like... But you shouldn't, because they are different. Let's just check we're pushing the right thing. We should be, because that's how it worked before. So if I go to 10k and 10k again, we do get both, because they're not over... Well, sorry, this needs to be a wasted 20k, and then we need to overwrite the last... Yeah. We shall see how that works. No, okay, so we're getting... Interesting. Right. What is happening? So if this goes to 0, hang on. We might... The buffer might not be the right size. I'll have to check the buffer in a minute. Okay, so that works. Let's check... So updating the particles. Let me think about this for a minute. Yeah, we need to check the buffer that I created, which is in here somewhere. It's just a bit further up. So let's just check the buffer for these particles. Is this the right size? Where is it? Load textures, load buffers should be here. Yeah, particle count, which is 20k, 2 times that. So as far as I'm aware, this is... Yeah, so we have that. We have this, which is just 2 times... This is mostly an experiment, more than anything. So it is definitely the same size. And particle data... I'm confused. Oh. Right. Okay, so maybe... Oops. I think that's the issue. Yeah, I think that was probably the issue then. The actual draw call wasn't drawing them. So if I do this again, the draw call count buffer was actually bad. We shall see. Yeah, okay, so there we go. So that's 20,000, that's 40,000 particles being rendered at once. I apologize for the frame rate, or the bit rate. And as they get deleted, the new one just pops in exactly at the beginning of the origin. Yeah, it's pretty good. Okay. So that was a good solution for what we needed. I just need to make sure that the buffer size is that big. Now the problem is, like, how do I define how big the buffer is for it to be? Okay. This is so tricky. So the problem is now for me anyway, is if I go into the compute shader and do something, I don't know, because we are going to have to do some like different effects for different particles, right? Let's just make the red one go on forever. So if the particle's set, okay, and again, we'll kind of make this make more sense. This is mostly testing stuff. Is equal to 1, right? If that is true, then, you know, oops, no, that's wrong. If I guess then this. Okay, I can probably just bear with my rubbish coding at the moment. I'm just kind of trying to. I'm thinking like 20 different things at once. I will improve this for a minute. So we're not going to reset the size effectively, unless the particle set is equal to 1. So that's the red one. The blue one should happen once and never happen again. But the problem is here we're going to have like a bunch of empty particles that aren't going to do anything. And we're kind of offsetting into a buffer. I just kind of want to see how this works. I don't know what's going to happen. Because the draw call that's going to be generated for the first draw call is not going to have anything in it. And the second draw call is going to have like 20,000 particles. Hello. Hi, Dev. Or X Lucky. X, yeah. How you doing, dude? Doing particle work today, so hopefully you're in for that. So I don't know what's going to happen here. This could cause all sorts of issues, but I'm kind of curious to see. Oh, interesting. So it just kind of freezes. Huh. Let's try that again. I might have done something wrong there. Right. Interesting. Why didn't it stop rendering them? Why is it interest? Okay. Oh. Of course, we need to start deactivating stuff. Oops. Alright. I forgot. We've done it again. Comment. Oh. Okay, you don't work like that. Okay, let's just go back. It's just fine. I think you do this at least. Yeah, so we need to use the other buffer that's tracking if something's active or inactive. Kind of distracting myself from my madness, working on a render graph pipeline. Ooh, for reflection. Particles are on my list, but I don't need them right now. Nice. Yeah, I'm glad I can be your distraction. Yeah, render graphs can be kind of tough, I have to admit. Getting that system set up so you don't get any circular dependencies or something, or buffers communicating with each other in a way that makes sense. Yeah, I can empathize. Right. Okay. So we have this increases by this, but we want to make sure this is only happening for particle set 0. Again, excuse my hackiness. I kind of want to see how this behaves though, without any like attempt at making this look nice. Sorry, making the code look nice. Like, can it handle this? Okay, so it just renders them anyway. Which is not what I expected. Turn this off. Kind of looks cool in its own way, but it's obviously not what we want. Alright. What do we do next then? If particle set is equal to 0, which is the blue particles, and the max age is equal or that, then we add 1 to our particle, which we set initially is, you know, huge. I think what I might have to do is start splitting these up into their own emitters, I think. So if I set this to, because we're not using this, yeah, I think we've got to be careful here how we write into this buffer. But yeah, does that work? No. Okay. Okay. Why are you still being rendered? I think this might be worth putting it in render doc, to be honest. Let's throw this into render doc and see what the buffers are trying to do. Because right now I'm not quite sure what's supposed to be I don't know what I've told the GPU to do effectively. So yeah, let's get this on. Classic render doc debugging. Let me know if no one knows what I'm doing right now. If you want me to explain render doc. I know some people in chat have heard me explain render doc a lot, but you know, I am totally fine with explaining it over and over for the people who are new. I'll explain it why we're doing this. This is at least a very, very quick outline anyway. I'm having to turn off some of the checks so we can record the commands that are happening in render doc, and then it can tell us what the state of the program is at that point, so we can debug stuff. So that's what it does. That's all that render doc is. We do need to copy over the shaders, so while that compiles, we'll do that. Because we don't copy over the shaders every single time when we don't need to. So, I don't think anything's new with the textures. We just have these fellas. It's mostly, I do them all because it's just like, you know, I can turn my brain off. I do it in release as well, so it's like more accurate. The shaders themselves don't get optimized really, so you know. Okay, and yep, then you just get frozen in time. Fantastic. All right, cool. So now I'm going to throw my program into this fella, but after everything's frozen, because I'm kind of curious what that means. All right, capture, and it's just going to load up everything. It's recorded. So what I'm interested in here is Oh yeah, the fill buffer. Oh, hang on. The fill buffers also needs to be incremented. That could be it. Where's the fill buffer at? So how much are we filling this up with? Indirect draw call count. Oh no, it's fine, it's fine. I just think it doesn't really matter. Let's look at our compute shader real quick. So we are interested in... I feel like I wonder if there's like an extension for a tree view. This would be easier than whatever this is. Right, so I'll pin that so I can just see it as well. Oh, wouldn't you pin 2? Yeah. Where's the other one gone? One moment. Oh, okay, it's there. It's just... anyway. Well, the shaders get optimized in the second compilation step. The SPRV to binary compilation done during pipeline creation. Ah, okay. Good, good, good. You can, as far as I'm aware, with compilers, though, set up the compilation. Right, so this needs to be set to C. So what I'm interested in here is making sure that the invocations of the No, it's okay, so the invocations of the draw calls are also fitting into the draw call count buffer. Give me a moment. Yeah, okay, so that's definitely happening. Right, okay. Yeah, it might be worth changing this just to 4K for now. And obviously getting rid of the 2 multiples, just so I don't end up making a mistake somewhere in the code base by accident. Because it is kind of confusing. Let's just make sure every draw call count is affected by that. We're not having any multiplied by 2. Okay. Alright, so I'm just going to rebuild that, which will take no time at all. And that is not used, apparently. Okay. Not that it matters, but anyway, let's reload. Just want to... Yep. Okay, so it's still freezing in time. It doesn't really matter what it actually looks like as long as we can look at the buffer. So, yes, I just wanted to make sure that the fill buffer made sense for the size of how many things that we've got. We have 2 draw calls. Okay. So... Right, okay, that's quite interesting. Now, if I did one draw call, just like no matter what, so it's doing 2 draw calls. The problem is it's drawing the other instances of particles. Now, what is this value? I've forgotten. This is the particle data stuff, so let's pin that as well. So this is that, okay. Now, if we go into all this, we have changes to... Okay, it's already C, thank you. So you have instance count. How do I make one draw call? Guaranteed. I think I can literally just paste this in. So as far as I'm aware, that's the multiple draw call. Right, so this doesn't need to be anything. So I believe, as far as I'm aware, this would be one draw call. Oh, we can't, hang on, sorry. No, interesting. Okay. So I'm just trying to work out what it's drawing. Okay. So if we do this again, no, okay, so it's doing the same thing, but I have a feeling it's drawing less. Alright, so let's look at RenderDoc a bit more then. I'm going to texture viewer. That's the red. That's the blue. So yeah, what I want to do is obviously only render the red in this situation. The problem is it's not respecting the fact that particles have been deleted. I mean, it does. So maybe my shaders are all stupid. Not these ones. Let's leave these alone. But this, right. So let me think about this for a bit. So this doesn't get updated anymore once this has reached a particular age. And my next question is then, okay, if that's true, what if that's the case? The problem is with that, then we might end up with a no, oh, we're in release. Oh no, it's fine. It should be fine in any, to be honest. Considering we're messing with shaders. No, okay. Just slows things. Just slower to load because of release. As far as I can tell, we don't return. So if the okay. Right. So this gets huge, right? Okay, I'm gonna this might not ever reach 0. Because that's what I'm saying here. It's like, don't generate the draw calls if we've run out of things. I kind of need to disable a bunch of things at once. I don't think this is a good way of doing it. With just a number that goes to 0. I feel like this needs to be yeah, because if we go in here and we do this, which is tempting. I don't even know if we have access to this, but no, we don't. Okay, we don't. So how we communicate between these two compute shaders? One, we generate this. We start with the highest value of particles, and when that compute set equals 0. Yeah, I think because we've set this to be 20k. No, because one particle set. Yeah, if I get rid of, I don't know, if I say like 99, I reckon this will work. Obviously, that's not gonna. That's gonna Oh no. Okay, so what is happening? I'm a bit confused here, so I'm just gonna kind of take a step back and copy this out temporarily. And we're just going to go all the way back to basics, what we had initially. Okay, so we had that. But I'm going to get rid of this as well, because that's even older. Right, okay, so when we do that, we should have one compute shader. Running particles. Yeah, they all die, which is by the books, which is normal. Why do they die? I think we simplify this logic quite a lot. If we want to regenerate the particles, we just say that, okay, for some particles, oops, okay, I didn't mean to do that. I copied everything out. So yeah, if the age is, assuming that we want an infinite particle set for particle set 1, let's just see. So we have, okay, we have particle, we have age, and we're going to go with particle set equals 1, which is the red ones. So we want infinite reds. Then we just overwrite whatever data index we were on. Did we have this plus offset thing? Yeah, we did. Okay, so that shouldn't have worked actually, because we had a alright. And then this. Okay. Fantastic. Okay, so we have particle set. If that is equal to 1, then we have an infinite one. Else, we actually disable stuff. So let's just see how that behaves. Okay, so they both die. Which isn't what I wanted. Oh, I'm an idiot. I didn't reset anything. 0.f, 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 which is the important part. Cool. Yeah, okay. So the red one's doing it. We had a blue one. I think there's less particles in this. Okay. And if I have this to 0, we should get the blue ones, and the red ones should go away. It is weird that there's like a delay. Right, okay, so that does work as far as I can tell. Now, I do want to see what it's looking like in a... Okay, hang on. Before we continue, let's just make sure for certain that we're not getting some weird out-of-bounds buffer read or something like that. When we do... Because this is important. The reason I'm testing this is because I want to make sure that the buffers make sense for what we're trying to do here. So, I assume that this is more complicated, the first one. Because effectively what we have here, let me can I just make this all... Oh yeah, I can just make this huge. So I'm just going to explain this real quick, mostly for my own sake. Let's make it bigger. Alright, cool. How big is that? Yeah, probably about 4 pixels. So effectively we have like a giant buffer of particles, which is huge. Let's not make it black. Which is huge, you know, which is like this. And right now we have this idea of like, okay, so halfway between them we have like a barrier. Well, not a barrier, like kind of like a gap. How do I zoom in? Okay, just scroll bar. Yep, so that wasn't quite there. Anyway, and then we have the fill tool, which is, you know, then we have what, the blue, and we have the red, right? And what I'm worried about, all the way around actually, we have the red here, and then we have the blue, right? What I'm worried about is effectively when we stop using the so when this gets deleted, so time passes, you know, can I copy and paste something? I'm a bit rubbish at this tool, I'm not gonna lie. Copy, paste, and then move. No. Okay, let's try it one more time. If this doesn't work, can't I not transform, edit selection? No. Okay. I don't know what I just did then. Anyway, I'll just do it again. Screw it. So effectively, we have this is the same buffer again. Actually, make this a bit more just cut through, so it's just not going to do this shenanigans. And we have the red spotting with the particles. Oops. Why are you there? Okay, so then we have like what? We're not doing blue. Time has passed. Like, you know, this is what. Let's go with white. This is like DT. You know, I think delta. And it's like, all right, like, can the buffers understand that this is no longer being used, but we're starting at this point onwards after they've all died. Now, what I can do is probably keep track of outside of the GPU when this happens, and maybe I can do something like, ideally what I'd like to do, obviously, because this is giant waste, right? There's like waste. I'd want to obviously do that where we have the red go onto here, and then the blue would go, you know, if we were to do this again, the blue would go on the other side, so like the blue would go here, right? Assuming that we, you know, re-triggered a particle effect. And we just kept using the data over and over again. Because, you know, blue is supposed to be an explosion. It's supposed to be like thrusters or something from like a rocket ship. So yeah, effectively that's what I'm trying to do. But at the moment I'm just trying to make sure that, you know, with a bunch of waste can... So yeah, I'm probably... assuming this works, the next step is to get the data to be written to the right place. And I think I need to track things on the CPU side to then tell the compute... So then I can tell the compute shaders... yeah, I'm going to write this down for a minute. I'm going to get rid of this. I don't think I got anything out of it. So... step, make sure... Actually, I can do this quick. I don't have to write this down. But I will write the other thing I said down. Let me know if any of this is making sense, right? If this is if anyone's like confused and wants to follow along, feel free to ask a question, because it's possible that what I'm trying to do makes no sense, and it will never work. And you know, you asking a question does help. So, but that's, you know, obviously that's only if you want to. All right. So let's just make sure we're not doing a out of bounds buffer read here. Okay, we're not. That would have gone wrong way earlier. All right, cool. So yeah, we've got a buffer on the GPU that's massively wasted right now, right? So what we need to do is effectively as we're losing particles, which is tricky to track because it's been 2 hours already. Ah, you've been drawing, nice. Yeah, good stuff. So effectively, we have this situation right now. So the next step is, step 2 is to figure out that the offset. So we need to reduce the global offset into the buffer when stuff is no longer used. No longer on the screen. Right. The problem here is that I don't know if this is even like how you're supposed to do this. I'm following a book called GPU Zen 3, and it just has it doesn't explain how to do any of this stuff. It explains how to pack data really well and stuff like that, but it doesn't explain how to do the GPU driven rendering itself. It just explains like how it's packed and how the buffers interact with each other for the actual particles themselves, not actually how to deal with the fact that assuming that you're rendering 40,000 particles and then 20,000 disappear, then like how do you make sure that you're just not wasting a load of space? And because the problem is if I if I have a particle buffer that's like 40,000 particles size, like huge, and then I delete, then this is all dead. It doesn't really matter if it's this side of the buffer or this side of the buffer. That's the issue. Like it doesn't matter. Like we're basically not using 20,000 entries, assuming that we've got rid of 20,000. Assuming this is a 40,000 size buffer, right? But if I was to then try and make a new particle effect, like how would I know like where to put the bloody thing, right? Like I need to write the data somewhere, like. So I need to make sure, I think, the idea with moving this red over to this side is so that when the red is on this side, when I don't know, if I do a red here, right? Go back to paint. Then I can easily slot in, like a tiny particle effect, right? Next to it, like here, right? Like this. Like I can squeeze in something here, and then like another one here, and then I can delete the blue one, and then move the purple one over here. Like that's my idea anyway. Like I only use buffers. Sorry, I only use particles. I can trigger a particle effect whenever I want, right? But I need to then like move the data that's being written to into closer to 0, so I don't end up having this situation where we have like a bunch of like dead space here, and I can always guarantee that there's going to be something over here that I can write into. That's what I'm thinking right now. I want to make a realistic game eventually in Unreal Engine. What should I focus on learning first so I don't waste years going in the wrong direction? It's my 3rd day of learning, or day 3 of learning. When you say realistic, I assume you mean 3D, right? There's so many things that you should learn, I guess. It's hard to know where to start. I would recommend not learning blueprints since Unreal Engine 6 deprecates and removes them. There you go. Yeah, don't learn blueprints. Thank you for that. I actually don't know Unreal Engine. I can only give you like general advice for like learning. But I would generally say the temptation will come about, Void, when you're learning Unreal. I don't know when it'll be, but it'll be like maybe, let's just pretend 6 months from now, you think, ugh, I don't like doing this. Make sure that you are stick with one game engine. Basically, that's what I'm going to say. There are a lot of game developers I've talked to who keep swapping game engines because it doesn't do what they want. I recommend, in my opinion, learning the tool well so it doesn't become an obstacle for the type of games that you want to make. Now, what does that mean? That typically would mean making smaller games, very simple games, so the tool itself doesn't get in the way. Because I feel like a lot of people kind of want to make it. They're like game designers in my mind, right? And they're like, oh, I don't care about the coding, I don't care about the tooling, I don't care about the actual development side of things. They just have like a cool idea in their head where they're like, oh, what I want to do is this, and I'm just going to try and find the easiest way to do it. But that works in the short term, but I think it eventually starts to harm you in the long term if you're not sticking at the same thing. So yeah, try to stick with the same. Oh, I know what you're talking about. Yeah, the 3D shooter game that was based on a recorded body cam using and learn. That's what you. I'm using blueprints. Well, yeah, be careful with. Well, like Luxie said, it is going to be deprecated in the new one. So if you do plan to go to Unreal Engine 6, be aware that that's not going to be a feature anymore. But yeah, whatever. Unfortunately, engines do this to you. They kind of change the tools underneath your feet as you're working with them. But yeah, just stick with. But despite that, if you do want to use Unreal Engine and that is the industry standard and that's the direction you want to go in, try to avoid the temptation of like using 20 different engines to do whatever you want. That's the only general advice I can give. I can't really say like, oh, there's a tutorial out there for you to do. I'd focus on learning C++ for now, and once you've done that, it'll be easier to learn other stuff. Yeah, okay, there you go. Effectively, you don't want I think the general goal for you, honestly, is to avoid the friction that comes with using Unreal Engine. And if that requires you to learn C++, then that requires you to learn C++. So yeah, that should be your like meta goal. That's like that takes a lot of things to do. But after that, then yeah, then pick goals that make sense for you, right? It wouldn't make sense for you, for example, to like learn how to do rigging in Blender and then figure out that you don't know how to open a project in Unreal, right? That's what I'm trying to. That's why I'm giving this general advice. So when you are doing other things, that the Unreal Engine tool itself is not getting in the way. It will still get in the way. It's inevitable, but at least you can limit it. Anyway, where was I? Splitting the buffers into multiple and moving the emitters around. I say that, the only reason I say that is because let's stick with Unreal Engine 5 for now. I guess my laptop can't handle the 6th version. Okay. Yeah, I don't know what it is with Unreal. It's such a massive, huge, heavyweight tool. I don't really get it. Anyway, but yeah, hopefully that explains what you should do. Anyway, okay, so next. Yeah, Unreal Engine barely works. Value making Unreal Engine 6. I don't know. I don't know anything about the engines. All right, let's see. The music's still going. It is not. I apologize. I missed that. Got too locked in. All right. Let me just change something real quick on my other monitor. Or the computer even. There we go. Okay. Okay. Very good. Very good. Thank you for bearing with me then. Right. So we're really on development right now. We're not really on study mode. Now I don't really know if this is a good idea, honestly. I wish there was a way to like know these things ahead of time, but there's just no way of knowing. Let's go through a more advanced version of what we're trying to do here. What is this? Compute shader particles with depth collision. So we demonstrate that. Okay, so I'm just gonna skim through this for a bit. Okay. So we waste a lot of space for a particle. How do you collide with the Alright, so I'm sorry I'm being a bit slow here. I'm trying to figure out I see, so that's actually quite nice. I am kind of curious, like how do you do the depth collision, which is, you know, this. Just more curious than anything. A simple project can take up to 97 gigs of RAM. Explained a lot of underlying issues. What? Surely it'd be 9.7 gigs of RAM. How does that even work? I don't understand Unreal. I don't get it. Alright, so we have a observe the particles fall through the floor, making them appear. The issue is okay, so resolve with depth collision. This is achieved. To achieve this, the particles yep. In the compute shader, we convert the world position. Okay. We use the view, the Z buffer from the carrier to origin projector space. Yeah. Okay. So we have all these matrices. Then we convert the projected value into. Sure. Next, we sample the projected pixel and compare it against the depth. The particle's depth. If the particle is within a certain range, we can apply a smear collision and add a bit of bounce to demonstrate the particle as the collision has happened. Right, okay, so it's actually not that complicated. So we just need to get the depth texture up into the shader, it looks like. My 6 gigs of VRAM laptop barely works for development. Damn. Yeah. Are you talking about virtual RAM? Damn, that's tough. Yeah. Well, I redid a game in a custom game engine end up using 7 gigs. So, well, I would never recommend anyone uses Unreal Engine. Wow, that's interesting. There we go. So yeah, I've just never been interested in using a game engine, so I just generally don't know the meta. To achieve this, we project the particle. Okay, so we just got to move some things into a different space. Then, based on that, we can sample the depth texture, assuming that we have it. But we would need to... as far as I'm aware, speaking of Unreal, Unreal slander against Unreal Tournament. Alright, so we have transform, we have vertex, world, position. Alright, so this doesn't seem too difficult, but I just need to like parse through this a bit better. Anyway, kind of get a bit distracted here. The next step that we need to do is basically build up emitters. Right now we have... we have the problem that... Let's run the game again. I feel like I've been talking so much. So, yeah. So we're using 20,000 plus to... the next thing that we need to figure out is exactly when do the particles die. The next question for me is... yeah. Let me think about this for a bit, because I need to figure out... yeah, let's throw this into RenderDoc. I think that was the thing I wanted to track next. Is to see what on earth's going on. Although I don't think it's that beneficial to have our particles collide with the depth buffer necessarily, considering it's just going to be an open space. Like, so most of the particles aren't going to collide with anything, right? But anyway, it might be cool. I don't know. It might be like an unnecessary side quest that doesn't really benefit the game at all. Right. So where's the but I will check that. I want to check the draw call count buffer and all that kind of stuff. I want to see what it's doing. And we're not like about to blow up. I think we just need to make sure, because at the same time I need to know, yes, the buffers have died, but also you know, if I have multiple particle sets, I need to move them into the like relevant part of the buffer. But I also don't want to do it like this is tricky because let me explain why I think this is kind of hard a little bit. Once I've okay, let's just do one thing at a time instead of thinking about the future. Let's because I've completely forgotten how to. I'm thinking too many things at once, right? Now let's just build. Let's throw our compute shaders in where they need to be. As that builds. Do. All right. Okay. Oh, by the way, just a side tangent. Do people like Twitch? I don't know if this is completely on-game development related, but I'm kind of curious. Like, people have said a couple of times, like, you should stream on Twitch, and I'm not saying I will do it, but I'm kind of like curious. Like, do you like Twitch more than YouTube? I don't know. I would be curious to know. I do not always, though. I see. Okay. There's probably more reach, but the viewer experience is ass if you're not subbed. I see. Okay. A lot of streamers and people. Okay. Yeah, straight retarded. Fair enough. Is not okay. Yeah, it's yeah, because people have said a couple of times like, yeah, I should try Twitch out, and yeah, it's just like yeah, it'd be good to know. I'll give it a go, see if it works. I'll have to have like 2 chats open, which is fine. The reason I started streaming on YouTube, by the way, is just because I prefer watching people on YouTube. But you know, if people, I would like to make your experience better. But you know, if some people here prefer Twitch, I will definitely stream on Twitch. I prefer YouTube because it has less ads. Creators should make money off it. I get that, but the amount of ads on Twitch, which can be set up by the creator themselves, is, well, annoying. I see. Okay, yeah, because I would have to do a bit of research. I think I'll do that today, perhaps. I might do a test stream on Twitch. Not none of you guys would probably know about it because I just stream like randomly with nothing on the screen. But you know, I'll try and get it set up and see. You know, okay, yeah. Regardless what happens anyway in the future, just so you're aware, I will continue because I like YouTube. I will stream on YouTube no matter what, right? So yeah. So what I'm gonna do here is just let this die and then capture a frame immediately and just kind of see, okay, what does that do? So you use uBlock with a custom script for Twitch. I see. Admittedly, I do have an ad blocker. You can probably see it here. But yeah, I am aware that Twitch is kind of awkward. Let's go to the text view. Hang on. Okay, so yeah, nothing gets rendered, and then everything gets rendered. Okay. And let's just look at the buffer for the, not the draw call buffers, but the compute shader buffers. So here I want to see, oops, not that. What are in the pipeline shader stage? I mean, I wouldn't make money off, not that I'm making any money really. So it's not like a money thing or anything. It's just kind of like I want you guys to, you know, have the best viewing experience. That's all. It crashes the player, but I reload it very quickly. That's not the bug. I say once you reach the affiliate status, you can decide when you want to show ads, like every 30 seconds, every 15 mins. Every 1 min, etc. Got you. Show ad every 5 seconds. Yeah, exactly. That sounds good. Yeah. Well, I'll give people the option. We'll try it out. We won't say it's what am I trying to say here? Let me think. With Twitch, we'll see what happens. We'll say we'll have like maybe a week where we try it out. And if it doesn't work out, we'll just leave it. If it works out, we'll do like a trial period. We'll see what happens, right? If it's extra faff, where nothing works, then I might leave it, but we'll see. Like I said, I want obviously you guys to have the best viewing experience, so the best we'll see what happens. Anyway, but yes, thank you for your feedback, guys. I appreciate that. Anyway, okay. So the push constants. That's what I want to. Where are the Where's the buffer that I'm trying to look for here? Because we're writing into a buffer at the VK dispatch level, but I don't see it. Usually you can go into the push constants, right? If I go into you know, here, and or let's say, I don't know, this. I go into this draw call. Oh, I'm in the wrong thing. Okay. Dirt. Okay, so let's look. What I'm interested in is... Yeah, where's the... Oh, compute shader. That would help if I'm in the right shader thing, right? Right, so we have delta, which is, you know, increasing by that X amount of time. We have the offset, and we have the particle set 0, which is fine. These are all good. Okay, so the particle data pointer is what I'm really interested in. As far as I'm aware, the... yeah, this just keeps increasing in value. So it's like these are getting computed still. Right, okay, so we are getting lots of particles. Let me think about this for a bit. Right. Okay, so what I want to do, obviously, is then go into here. Now, are these the same? Yeah, they are. Okay. That makes a lot of sense. So what I'm going to try and do, anyway, is reduce the waste, because this constantly just keeps updating. Or at the very least, reduce the amount of draws. But I need some feedback, honestly. I need to know... Let's close this for a minute. How can you like Vulkan, dude? Stockholm Syndrome. There you go. It's simple as. No, I don't mind it, to be honest. No, real answer. I'm sure there are other, you know, cleaner APIs out there, but it's not that difficult. A lot of the hard parts, in my opinion, of graphics are when it comes to the actual graphics programming. Alright, yeah, that's still good. Let's change the music. I feel like we get a repeating music. There we go. So what am I trying to do here? Let me think for a second. Yeah, so we need to be able to communicate with the compute shader after it's ran. Otherwise, there's no way of knowing what to do. I don't know how to do that, though. So if I have a buffer, and it's not CPU, it's only local, it's only VK device local. Is there even a way of getting any data out of the buffer, right? Because I'm writing to a buffer that's VK local. I don't want to make it host visible. But it looks like I would need to be able to read from a particle buffer to know exactly when a particle has died, right? Because that would tell me the W component of the position, right? The problem with that, which is kind of hard to quantify, honestly, is... let me think. It would slow everything down because it's now... The compute shader is doing a lot of work to communicate with the CPU. And I would be reading from a buffer, which is kind of like extra work than just writing to a buffer. because there needs to be like two-way communication almost. Because it needs to be read-write. Now, if this buffer is read-writable, we need to have two of them on the CPU. Because, you know, well, I don't know. If it's readable only, does it need to have two? I don't think it does, actually. But anyway. It's maybe possible that we make a different buffer pair particle set. And we do like a less, like we don't do the whole particle buffer itself, we do a different buffer that we write into, and maybe that's better. Respect Vulkan devs. Appreciate that, dude. Vulkan is nice once you get through the initial setup burden and have stuff abstracted, like VK Bootstrap. Will help, but it's not that much, yeah. Though I get why you might be hating it compared to like DirectX or /OpenGL. Yeah, that makes it. Yeah, 100%. It is awkward as hell to get started. Especially with Vulkan 1.0 being as asinine as it was to work with. Vulkan 1.3 is a lot nicer. Oh, 1.3 plus anyway. If only I had the VK image copy stuff and all that kind of rebar accessible constantly. Because then this device local and non-device local buffer stuff would not be an issue. So what I'm trying to do here is set up a... I don't know how to solve this in a way that makes sense. Maybe we can do something on the compute shader. Yeah, it's entirely possible that we could take our offset and kind of subtract values from it, assuming that it's not 0, based on how many particles have died, or something like that. You know what I mean? Like, obviously we don't want a negative number, so if, you know, this is just a pseudo code right now, but you know, if actually let's do this slightly different. So let's make a new variable. So uint buffer offset equals 0. Oh no, equals whatever the offset is, and then we just say, okay, you know, activity count, because this is a buffer that we're adding to, well, subtracting from, so it needs to be the, so we have total number of active sets, right? Offset is not equal to 0. So we have this guy, we can say, okay, make that negative. This isn't quite what we need. We need the other way around. We need like another variable here almost, like a deactivated set, which we can subtract. This is how many. Yeah, what happens if we did this? Right, this actually might be insane, but let's just see. Crazy idea, right? This is global to everything, but maybe we can just take this, and instead of having this hard offset, which comes from this guy, we have the activity set, which gets subtracted by 1 if a particle is dead. Alright, let's try that, right? That might be the solution here. Instead of you having an offset, hardcore offset value, I think then we're going to have a... If we're going to do it like this, we're going to have each particle effect is going to have its own activity set, which then gets offset. Then we can just be like adding less. The problem is though, This doesn't quite work. The reason is, well, let's just pretend, for example, we have 3 particle sets that all have 10k each, and one of them degrades into 0. This value will be per particle set, right? Meaning that this would only be 10k for 3, so this would be like 10k for 1 particle set. We're close though. I think this is the way. 10k for a particle set, 10k for a particle set, right? What we could do is have a global, maybe like a global, like and do some maths maybe to like work out. So a global active or something equals like 30k, and then we take that by the, so then if we want to do anything, we do that, we go, okay, global activity divided by particle set. No, all the way around. That would be a division by 0. So particle set, global active, like that. So the global active, hang on, we've got to be careful here. Is equal to the current offset. So that if this was 20, and then we add the, hang on. There's a bit of maths here that we can probably get away with. I just need to keep working on it. So this is the total number of, this is the size of, almost the size of the buffer, right? If we have a, where are we in this particle set? We have this, which tells us how many are active per particle set. So I think this is what I'm trying to say. So you have an active particle set divided by the global. If this becomes 0 over something, then it's just 0. No, this is going to be a... this integer division... This would be an integer division which wouldn't work. So effectively, what the answer I'm looking for is 10k. What makes 10k, 20k, 30k, right? What I need to do is, if we have a activity set of this, then we need to do a like kind of an addition for each particle set. Then we reduce by 1, you know, I don't know, you know, minus, you know, let's say 10 die in, let's just, because of the can't be bothered writing decimal points, let's just say 1,000 die on particle set 2, which is the middle one. Then the, not 100k, sorry, say 1k actually, on particle set 1, then this would be the same again, but this would be 9k. Alright, That's like time passed. And then yeah, effectively what we'd need to do is, I don't know how expensive this will be, but for so uint is this, that is less than that. Then we uint global offset equals 0, and then we just say, okay, based on kind of like this idea. No, wrong. Something like I dot particle set or something. What I might do is put the amount of particles that are active in the particle set itself, perhaps. Oh no, this is not going to work. I can't do it per particle set. This needs to be per effect, not per particle set. We can have multiple effects within a particle set. So it's not particle set, it's particle effect. How do I track that? I don't have a way of tracking this. So how many times have we done this? Because we could, like I said, we could have like 7 explosions all happening at once, all from the same particle set. We then also need to track how many, like, let's just say we have 7 particle sets happening. All 5 of them have a constant effect that's constantly going all the time. And then we have a the other 2 particles are like having explosions happening all the time, right? And they can't overwrite each other's data, only when they are not visible anymore. So when one particle dies, we need to be able to reuse it in a completely different place with a completely different particle set for another explosion, right? Otherwise, we end up wasting space. I think what we could say is particles that don't die, we just make sure they're done first, so they're always ordered properly. But that's kind of like hard to discipline in myself, really. I would make things more less complicated. But yeah, I need to. I don't want to have like small buffers. The other obvious solution is like, we have like a ton of small buffers. How do I check if we have a particle set per... Let me think. So we have multiple particle sets. They have different effects that happen. We need to put them in different parts of the buffer, otherwise we end up wasting space. And I don't want to Is that how it's done though? Is it? Am I just making my life harder by having like one huge buffer instead of one, like loads of little buffers? The overhead of that though does cost. Let me think. So if I had individual buffers for each part, even with particle sets, it's the same issue. Let's just say I had like, I don't know, 10,000 elements in one particle set. And they're constantly being deleted over and over again. I had the same issue where I just run out of space if I don't clean up after myself. And, you know, we need to allocate enough space that we have, you know, these particle effects happening. This is tricky. This is all about memory, so might have to do a bit of research on the GPU Zen book, maybe. Which maybe, because I did stop it prematurely. But let's look at sorry, it's a bit waffly this, I have to admit. I feel like there is some equation that we could use, but I don't really know what. GPU Zenbook, which is like I said, I do own this book. If you saw my video about how to become an expert, I show this off in real life. But I think maybe let's put this in the middle at least. It might be worth going through this a bit more just to see. Yeah, there's packing here, but also the workflow, I think. Because I think what the problem is, we don't understand enough to know what to do for the actual simulation. Not necessarily the draw calls. I think we've got that pretty much down. So yeah, that's the thing I'm going to try and do next, I think. Is work out how, you know, because we do need, again, we need to sort them, because otherwise transparency breaks, as you can see in my simulation. So we do need to do this swapping on an individual level as well. I don't think we're going to do light clustering. You can see that's the particles not sorted. So yeah, I think I'm going to do that. I'm going to make sure that I understand what I'm doing a bit better when it comes to this, so we can actually get some. Even if it doesn't tell me what to do, I think I just need to get closer to the answer, because this is getting tricky. Okay, I'm going to share my Discord server real quick with you guys. There you go. Now, like I say, on most weekends, I can't stream for very long often. So this is going to be it. I hope you guys enjoyed the live stream. I'll try and set up Twitch and stuff. Yeah, we're done. Yeah, like I said, Sundays are going to have to be short. Just because, you know, I'm streaming in the middle of a kitchen. Which isn't great when people are around and stuff. So, yeah, that'll be that for now. I hope you guys enjoyed the stream, though. I very much appreciate all the feedback and help along the way. Yeah, take care, guys, and I'll see you all in the next one. All right. See ya. Bye, guys. Bye, 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 bye.